Hi everyone. I'm decided to make a review about calculus and vectors. Calculus and factors together. I'm trying to make it a review, very short review, covers almost everything. Something good if you want to get 80, 70, 80, that's really good. So we start by the word calculus. The first thing about calculus when it comes to your mind, it will be the derivatives. Maybe if you're a little bit more rigorous, you say limits comes first. But no, I'm gonna start with the derivatives. The formal definition of the derivatives is that limit of delta x goes to 0 of any function plus delta x minus f of x divided by delta x. Or the formal definition of the derivatives comes from this. It comes from this. Everything that you know about derivatives, everything by everything. It comes from here. So for example, everyone knows, I hope everyone knows, that the derivative of sine of x is cosine of x. If we want to show it using the formal definition of the derivatives, we say it's the limit when delta x goes to 0 of the function which is sine of x plus delta x minus sine of x divided by delta x. And from here we take, okay, delta x goes to 0, the limit, say the limit. We see that is x plus delta x is two things that add together and we give it to the sine function of the direct function. So you can use the double angle formula. It will be sine of x cosine of delta x plus sine of delta x cosine of x minus sine of x. This comes from here and this from here, and the whole thing will be divided by delta x. Cool. So from here we notice something. We know that cosine of delta x for small angle will be just 1. So this thing will be 1. But we cannot simplify the delta x for the sine, because if simplified with the sine will be, this will be 0 over 0. So we have to take it slowly. So we use it again, limit when delta x goes to 0. I say this is just 1, so sine of x. We can move that one over there, sine of x divided by delta x plus sine of x, sine of delta x, cosine of x divided by delta x. For this one, this is 0. 0 divided by anything will be 0. So it will be 0 plus limit, let's say the limit is the same thing, because we didn't express it for this one yet, of sine of delta x cosine of x divided by delta x. And we know for the small angle for the sine, it will be so if sine is a small angle, it will be the argument. This is delta x divided by delta x times cos of x, and this is just 1. So the answer is cos of x. This is the same thing with all hyperbolic. Anything maybe come in exam, so that this is that. You just use that formula and apply it, and life is beautiful. It's gonna be perfect. So this is the first thing of the thing that you have to understand. You have to know about the derivative. If you're going to the exam, you have to know the formal definition of the derivative. Otherwise, you're fucked up. Yep. So I hope no one gets fucked up. But being fucked up is just part of life. So that's the first thing that everyone have to know about the derivatives. Second thing that everyone should know about the derivative is that the derivative is an operation. You can apply 1, 2, 3, 4, 5, 6 like punching. Like you punch 1 time, 2 times, 3 times. Same thing with the derivative. You can differentiate 1, 2, 3, 4, 5, 6, whatever. If we differentiate the function first time, it will be the first derivative, and that's the first derivative. When you can differentiate it again, take the second function, the function that you got, differentiate it again, you get the second derivative. Can apply the same definition, and so on, and that goes so on. The first derivative is important because if you want to find the maximum or minimum of a function, and it's stationary points. But all of those higher derivatives will come into play once we goes to something called Taylor series. Taylor series is a series that you can use it to approximate any function. It's easy. The Taylor series, if you have a function g of x, right now we're just dealing with one dimensional function, you can write it as a series, a series. If you want to find this Taylor series, you have to find about a specific point. So say you want to find it about x naught, so it will be g of x, g at x naught, and g of x like for any value. Then take the first derivative at g naught at x naught, and divided by 1 factorial, which is 1, x minus x naught to the power of 1, plus take the derivative again at that point divided by 2 factorial, then x minus x naught to the second, plus g to the third, like take the third derivative of the function at x naught divided by 3 factorial, x minus x naught to the third, and the series goes on to infinity. So any function can be written as a sum of binomial functions. Where this thing comes into play, for example, you can write any function. Imagine that you want to write sine of x squared as a Taylor series. Therefore, 3 non-zero terms. Say okay, like sine of x, like you think you're smart, like this is an easy question. So he says I want x naught is 0. So we go into the function g of x naught, which is sine of x is sine of 0 squared will be 0. What's after that? What does the rule tell you? Take the derivative, should be 2x cosine of x squared. This is a prime for any point. It tells you to evaluate it at that point. So this thing will be evaluated at that point, which is f(x) equal to 0. The function will be 0. And then you take the second derivative and the third derivative and the fourth, and so on, and substitute it back into the equation. I'm going to find the term after that because it shows that the term after that is actually non-zero. It's kind of obvious that the term after that is non-zero because cosine will be 2. We will see. So take the derivative of this one. It will be 2 cosine of x square, this is the chain rule, plus 2x times 2x. Take the derivative of cosine will be sine of x squared, and there will be negative. This is the third derivative of the function, and then you evaluate it at x naught equal to 0. This term will be 0, and what's left is that this term, so f(x) third derivative will be equal to 2, and so on for the higher derivative terms. So this is the third derivative. Everything before that is 0. We start with the third derivative. Substitute the equation back here, so g of x so far, we can write it as, they told you that's the third derivative, so it's 2. X, what's x naught is 0, so x cubed divided by 3 factorial, and 3 factorial, and if factorial is 3 times 2 times 1. Like 6 factorial, 6 factorial, 6, 5, 4, 3, 2, 1. You multiply them together and give you the answer. For this thing, it will be 3 times 2 times 1, which will leave us back x squared divided by 3. So this is the first term, and you can go to higher terms and find the overall Taylor series. So this is the second application, and this is the first application of derivative and the most important application of derivative in 1D. Finding the Taylor series about the specific point. Last point to say about the Taylor series, it's a series. So any series have two things. It either diverges or converges. What does that mean? Diverge means you add a term and it will go away. Add another term, it will go another value. So you cannot say like this is not very good. Not a good function. Like sometimes here, sometimes give you value this one. It does not converge to specific value. By converging series, it converges from its name, converging, converges to a specific value. It tells you something. Imagine if you have a function like x squared minus 2, and I want to find the Taylor series. Right now we know how to find the Taylor series, but any value. But this time to tell you find the Taylor series, I want x naught is equal to 0 again. But right now it asks you something else on top of that. It asks you to find the radius of convergence. The battery is gonna die soon. So we go to the function and we find the nearest singularity, which means denominator because it's 0, and just find whatever value. So x squared minus 2 equal to 0. So x is equal to plus or minus square root of 2. You have the nearest singularity and you have the point. The radius of convergence is the distance between 0, well, the point in which you are actually taking the Taylor series about, and the nearest singularity, which will be square root of 2 or negative because it's the same distance. So the radius of convergence in this case would be equal to 2. So any value that x less than 2, this Taylor series will converge. More than that, it will diverge, and this is Taylor series.